So, very good evening, students. I'm here for another session of our subject multimedia systems. I hope my voice is clear to all of you and screen is visible. So, in this session, we are going to discuss various different topics related to identifying the key concepts and techniques involved in content-based retrieval for text as well as images. We will also cover or explain the importance of content-based retrieval in multiple multimedia systems as well as applications, describe different methods of representing video data, including frame-based and object-based representations. We also explain the significance of color models such as RGB, YUV, HSV in video representation and processing. And we will also examine the video compression techniques, including the spatial and temporal compression methods. And at the end, we will describe the standards such as MPEG and H.264 in video compression and their impact on multimedia applications. So, without wasting time, I'm moving further. Multiple monitors. As you see in your image, that nowadays it's a trend to fit multiple monitors when they are needed. It will enhance the performance, efficiency, as well as multiple more scenarios are there. Like multiple monitors refer for the use of more than one display screens connected to a single computer or a workstation. In multimedia production, having multiple monitors offers the numerous benefits to professionals. So, first major benefit is increased screen real estate. So, it expands the workspace, providing additional screens real estate for organizing tools, applications, and project elements. This expanded space allow multimedia creators to spread out the workflow. So keeping different tasks or projects separate while maintaining visibility and accessibility. If I'm giving you an example like who is using multi monitor setup, like those who are using trading are using multimedia or like multi monitor screen. Sometimes gamers are also doing the same thing. Production houses, those who are uh, creating animations, sometimes they are like producing movies or animation work, they are also using multi-screen. So benefit of using multi-screen is that we can have multiple tabs on different screens. Like if I'm having 5 tabs that are open, but if I'm using only one screen, that only one screen at a time can be visible to me. If I'm using multi-monitor setup, so I can have access to like 3 4 screens at the same time when it is required. So I can visualize 2 or 3 screens simultaneously without exchanging them like one after another. So that is uh, decreasing the efficiency if we have only one screen. Here in the picture, you can easily see that all 5 screens are uh, connected to a single computer or a desktop or a laptop in which the person is visualizing many different things. So the screen one is showing the different content, screen two is showing like graphical visualization, screen three is showing something different, 4 and 5 are also describing different things. So it is the benefit that the person do not have to switch the screens each time when they are needed, because all five are opened on different monitors. So this is the advantage. Second is the graphic card. So multi-monitor facilitate the efficient multitasking. So creators can have different applications or projects open on each different screen simultaneously, which is enabling them to work on various tasks without the need to consistently switch between windows or like tabs. Third is the monitors, like multi-monitor enhance the collaboration in multimedia projects. So team members can share screens or view different like scenarios so that the project simultaneously, which promoting the better communication and coordination. Like if this person want to share a screen, so the person knows which screen he want to share to the users, because on the other screens the person has different visualization, so he can explain another things based on the visualization. Then the layout, we have different layouts. So these are the benefits of using multi-monitor nowadays. So I think this is not a very like theoretical question, because it's kind of practical thing. If you are saying that how we do that, it is simple and easy task. We can have HDMI port and we can easily set up multi-monitor screen. Next topic we have is a bitmap. What exactly a bitmap and how we are using. So bitmaps are also known as a raster graphic, are a fundamental ways of representing digital images on computers. So building block in a bitmap is a kind of pixel. Do you guys know what exactly a pixel is? Have you ever heard the word pixel? If anyone has any information about the pixel, then they can write in chat that what they understand from pixel. Vinith, please write what you want to say about a pixel, because it is a very fundamental unit in graphics that we are going to discuss. So different bitmap images are there like JPEG, PNG, GIF, BMP. I think you almost all hear the name JPEG and GIF, because GIF are nowadays very popular images which we are sharing with each other as a means, and JPEG is the simplest format in each like whether it is a mobile or a computer to store a picture. So it's a joint photographic expert group. This is uh, simply a JPEG. So it is a compressed image. And we have another format of image which is a PNG. So PNG is a portable network graphics. So the extension is exactly different from the JPEG. Uh, Divya Jyoti is saying that pixel is a picture element. Yes, it's we can say that it's a picture element, or we can say that if we are using a monitor or a display or anything, then the smallest unit of a display is called a pixel. Means like we have a like ratio of my screen is like 1920 into 11 or 13, or like 1170 or 1190, then these 1920 are the number of pixels in from left to right or from top to bottom. So these number of pixels are supported by the monitor or the screen. So these are the size of pixel. It is the similar as we can say that the smallest body part of a human is cell. So human body is made of cells. These cells are connected with each other and forming different body parts. So in the same way, we can easily say that the smallest screen or the smallest screen element is a pixel. So if we have an image having pixels like 360 into 360, then these 360s are the pixel from left to right and from top to bottom. So like I'm going to describe these in like further communication. What exactly a color depth is? We have different scenarios. What is a color depth? Or we can say that monochrome to millions. The amount of color information a pixel hold determine the overall color depth of the image. Or we can say that simpler bitmaps use just one bit per pixel, resulting in a black and white image. As the number of bits per pixel are increased, the image can display more colors. For instance, 8 bit per pixel allow 256 colors, yani, or 2 raised to power 8. So which is enough for basic color display. Higher bit depth like 24 bits per pixel, which offers in like photographs, enables the millions of colors, creating a rich and realistic image. Like nowadays, if you are going to buy a 65-inch color TV, then in that case, if that color TV is whether it is a organic TV or a kind of like full HD TV, then full HD TV means we have more than 4,000 pixels, or we can easily use that these 4,000 or like 4K quality image has uh, millions of colors supported. How these colors are formed, we can use or show here in the uh, diagram. Like I'm showing this diagram, it is showing that if one pixel has like a number of bits supported by a pixel. If this single pixel has only one bit, then number of colors are supported is 2 raised to power 1. It means whether that color is white or black. So number of color possibility is only 2 if each pixel has only one color at a time. This is the simplest image. That image is always a black and white image, and the size of the image is always smaller because we have less number of colors or less number of bits per pixel. Second is, if we have 2 bits per pixel, means whether at the same time that pixel has more than one bits, or we can say that we have 2 bits at the same time. So in that case, we have 4 different color possibility there. So it means the number of colors supported by the each pixel is 4. In the same way, if we are increasing from 1 to 2, 2 to 4, 4 to 8, 8 to 16, and 16 to 24. If we are moving to 24, then it means 2 raised to power 24 colors can be assigned to a single pixel. Means these are the number of colors to be assigned. It means these different colors are there which can be obtained by a single pixel. So how many of these are? Like 16, 777, 216. These are like in millions. On the right side, I'm showing a color palette which is showing something that if you can hear what exactly these numbers are and how these numbers are relating to the image. So you can easily check that what exactly we want to show On the left or on the typical right side, like here, if I am annotating this, I'm describing about this. So what exactly this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E. So these are the, we can say that hexadecimal number. Hexadecimal numbers are always starting from 0 and which are ending to E. I think you have a basic fundamental knowledge about these uh, like decimal numbers. We have decimal, octal, hexadecimal, and binary. So binary has only two numbers. Then we have decimal. Decimal are that we are showing in mathematics like 0 to 9. Then we have a octal numbers. Octal numbers are always starting from 0 and ending at 7. So each has 8 bits combination. Then we have a hexadecimal. Hexadecimal means we are talking about 16 number pattern. So in 16 number pattern, we are starting from 0 and then we are moving to E because we are using hexadecimal. So 10, 11, 12, 13, 14, 15 are replaced by A, B, C, D, E because if we are representing 1 0 instead of A, then 1 0 can be described as a binary digit, or B is like 1 1. 1 1 is also kind of binary digit. So we are avoiding the confusion and then we are representing A, B, C, D. Then what are the right side format? So the right side format 0 0 0 0 0 0, it's the uh, sequence of the number like we are describing to the color. Like black always has 6 times 0. Then the red we have double F, double zero, double zero. Then the green has double zero, double F, double zero. This is the color coding we have. So when we have a particular number like 333, so this 3 is for single pixel, this is for another pixel, this is for another pixel. So how we are showing that? We can easily see that if the number is 3, then 3 means the color is blue. So here the leftmost bit or the pixel has a blue color. In the same way, if we show that all the upper row has a only blue color, we can easily show that this full row, this full row is of blue color. In the same way, uh, green is represented by number 2. So if at the bottom we have 2, 2, 2, 2, 2, then the bottommost row has color green. I hope this looks easy to understand for you guys. I'm checking like meanwhile if any feedback that we need to address. If you have any questions, then you can write in chat so that I can answer your question. So what exactly this is? We have different colors and these colors are obtaining an image. So this image has different colors, like one is represented by a red and where is white? White is represented by 4. So here we have a combination of 1 4 1 4 1 4. It means red white red white red white. On the left side we are showing 0, on the right side we are showing 0. So 0 is representing the black color. So this particular column is black, on the right side column is black, and in between we have two rows are of yellow. Yellow is represented by 5. So these two rows which are together are represented by yellow. If anyone has any doubt in this representation, then please let me know. And these 16 colors are represented by, if we have a bits per pixel having 4. So we can have 16 different colors to be given or to be awarded to a particular pixel. Like this is the leftmost pixel. If I can use some drawings. If this is the leftmost pixel, so what are the possibility of color combination? We can choose any of these colors for this particular pixel. So how many colors are there we have? We have total 16 colors which can be chosen to provide a single pixel. So right now that pixel is blue, but we have 15 more options to for this particular pixels. This is what this is uh, bits per pixel having size 4. If we have bits per pixel having 8 size 8, then we can have this particular table has 256 different color combinations to be there to support it. The if we have more number of colors, then the image would be more realistic. More realistic means it is showing different colors. Like for red, we have like hundreds of different red colors are there, which has like little difference between different red colors. If you have any questions, you can write in your chat. Otherwise, I'm moving further so that we will cover more topics. Then this is what we are showing. So against each number that we were showing, like we are showing these as a number, now we can show the hexadecimal code of against each number. Like we have 0000 F. So if you know what exactly this is, we can easily mark that. Uday has some question like we have like 64 bit is same as bitmap. Like 64 bits is same as bitmap. I'm not understanding the question. If you can describe further, but I can easily show you that we can have like a number of pixels. Like now we are representing this table up to 24, but we can have more number of bits per pixel as well as to show further. Like after 24 we can have 32 or 48 or 64. It means we can have number of more colors are there. Otherwise there is no meaning of using these bits per pixel. Bits per pixel means this is what we want to show. If we have more number of colors other than this 16 777 216, then we can display it. One more thing that we can also check that if our screen size is greater, then we have to choose. We can choose the display which has more number of colors. Like if I discuss practically with you, like if you have a low bits per pixel, like we have 360 into 360 image, which has only 360 colors, sorry, 360 pixels from top to bottom and from 360 pixels from left to right. If we see the same image in our mobile, which has a smaller screen, so it is not like spreading the image because the screen size of mobile is shorter. So the visualization of the that particular image is good. We easily see that image. But if the same image with 360 into 360 combination, if we are displaying that particular image on a larger display like 65-inch or more, then we can easily identify that it is showing like image is kind of stretching or spreading. It means the quality of the image is not supported by that screen. So we have, or we want more number of pixels uh, to represent a good image. Like if we have a like if I display something that is easily visualized in our normal WhatsApp image that we are sending from one place to another place. In the same, if we are displaying the same image on a larger screen, that image is spreaded because the reason is number of pixels are more, but the image is not supporting the number of pixels. That's the reason. So in the same way, we are showing the hexadecimal code to each pixel, like 0000 is a hexadecimal code, and we are showing this code to represent different colors. Then we have a vector drawing. Vector drawing is what? It is referring to the creating digital images using geometric shapes like lines, curves, and polygons defined by mathematical formula rather than individual pixels. The approach offers several advantages compared to traditional bitmap images like a photo. So these bitmap images are more helpful for like animation or a different task. So vector drawings refers to creating digital images using geometric shapes like lines. So what are the benefits? Benefit is scalability without compromise. This is one of the advantage. Second is sharp and crisp edges. We can have smaller file size and editing flexibility. So we can easily edit these kind of uh, images. And what are the tools we can use for these kind of drawings? So we can have uh, Adobe Illustrator that can be used. We can have Inkscape, like free and open source, so anyone can use it. Then we can have CorelDRAW to draw these kind of drawings. Sketch tool is also there, but it is a kind of paid, and Affinity Designer. So these kind of tools are there. And what type of images we are creating using these vector drawings? Like if we want to create a logo or icon, so it is vector drawing or vector graphics is a good choice for creating logos as well as icons because of their scalability and ability to maintain sharp details. So if you are going to create some logos, then you can use vector drawings. Then if you have some illustrations, like vector drawings are well suited for creating clean and crisp illustrations, infographics, and something like cartoons. So vector drawings are good for cartoon animations as well as. Then technical images or technical drawings, due to their precision and scalability, vector graphics are also widely used in engineering and architectural drawings, like those who are creating uh, architectural maps of different objects like houses or animation. Then fourth is graphic designers. If many graphic designers or design elements such as like charts, graphs, text layouts benefits from clean lines and scalability of vector graphics. These are to be formed by these kind of vector drawings. So these programs provide tools for creating and manipulating vector shapes, defining color and gradient, and applying various effects on these kind of images. Thereafter, we have lossy graphic compression. Lossy graphic compression means it's kind of technique used to significantly reduce the file size of image by permanently discarding some of the data. So this trade-off between file size and image quality makes it like ideal for situations where smaller file sizes are crucial, such as fast image loading on website, efficient storage and transmission, share images over limited bandwidth. These this kind of topic we already discussed in our last session when I was describing the benefits of lossy graphics or compression, the benefits of the compression. So we can easily see that in below image we have one original JPEG of a dog's face having size 824 KB. Then we are reducing this original image to 50% lossy compression. Then the image has the size only 76 KB. And we are again providing the compression and 80% lossy compression. In that case, we can have 38 KB only. But visualization is showing that there is no such differences we can visualize using a like naked human eye, because uh, the compression is like 50 or like 80% lossy compression that cannot be recovered, but we are good with the quality like 50% or like 80%. And where we are using these kind of images, uh, the first point is fast image loading on websites. If we are providing heavy images like 1 MB or more than 1 MB, so these images cannot be loaded on the uh, like smaller or larger screens. Reason being, the page will be open, like the text will be open, but those kind of images which have a higher size, like if the whole size of the page, because the one web page has only one image, the whole size of the web page is 500 KB because it has only text, and one image is having size 1 MB. So text will be loaded faster and image will be loaded slower. So we have to wait for the image if we are providing heavy quality image. So providing this, what are the different ways? We are compressing the image and we are providing the compressed image on websites. So the benefit of using that, those who have slower internet connections can also like load those kind of images. Like if we want to choose which file we want to show on the website, like 824 or 76 or 38, the choice will be whether it is 76 or 38. We are not going to load 824 KB size of image in the websites as well as in mobile applications. Second is efficient storage and transmission, because another factor other than the loading or loading of the image is a storage, because each time when you are opening a website or application, then it is storing that data in your cache memory. So it will and the cache memory is limited. So each time when you have some data on the page or application, it is creating a cache, so that if you are opening again and again, it will be loaded easily. But the file size is greater than the limited data is consuming the whole cache. So cache is full. So in that case, more data will not be loaded in the cache. You have to flush the cache if uh, like the particular application is lower. Then sharing images over limited bandwidth. Third main issue related to images is a bandwidth. because if you are using fiber connection, it is good, like you have 1 TB or like 1 Gbps network, then you have no issues about the speed or bandwidth. But those who are using mobile network, having downloading speed from like 5 MB to 15, 20, 30 MB, so those will face the difficulty about the bandwidth when we are sharing the image. If the like your mobile is capturing a single image of like 8 MB or 10 MB, and you want to share that image in original format with 10 MB of size, then how many images you will forward? Like you have an internet connection, you are having a good quality internet connection, and you are sending those images to someone else, and that person is using a mobile uh, network, and your 100 images, 100 MB each, like 10 MB each size, it means 1 GB data will be downloaded on mobile network. It will take the whole day or like 1 hour or more to continuously download the image, and it will like oversize their bandwidth as well as their daily quota of uh, network. So whole identification of this is we are choosing lossy compression for apps, for websites, as well as if we are sharing images to someone else. And how this lossy compression works. So here are some standard techniques used in lossy compression. First is discretization, second is quantization, and third is transform coding. So uh, like what exactly a discretization is? So continuous color values are converted into a limited set of discrete values, reducing the number of bits needed to store the data is kind of discretization. And what exactly a quantization is? So colors similar to each other are grouped and represented by a single average color, leading to a loss of details in some areas. And third technique is transform coding. Transform coding is the image data is transformed into a different domain, like we have frequency space where compression can be more efficient. So we can have these standard techniques that can be used for lossy compression. What exactly a quantization is? Quantization is like I'm saying, if we have 50 pixels, all pixels are of same color, like I'm displaying, is there any show? Like this is an image of a dog. Most of the colors in this image are related to black, means some are some other colors, like if I'm choosing the annotation and showing this part of the image, like this part of the image has almost all the color elements are black. So instead of like total pixels in this area are I'm assuming like 40 pixels, I'm assuming. So 40 pixels nearby all have the same black color. So instead of representing all these 40 blacks, we are like representing 15 pixels for this black representation. There will be no change, because if we are reducing some of the pixels from these 40 to 10 or 15s, the color combinations will be same, because we cannot have different colors for each pixels. We are grouping those color those pixels which are having the same color. like see in the same way in this area we can also reduce the same thing, we can also reduce the same thing in this area, we can also reduce the same thing in this area. So those nearby pixels which are of same area, we can group them and display the compressed image with lower number of pixels. If you can easily like if you stack some brain on your combination of this pixel as well this pixel, you can easily see that here there is no pixels formation visible. But if you see this image here, there are some linings there. If you stretch the like your eyes and you can visualize that there are some boxes visible. What it means? That it means that this quality of this image is reduced, but here the quality of image is crystal clear. So what it means? The number of pixels are reduced. If we are displaying this third image on a larger screen, it will easily show that this is a compressed image. But here, if we are displaying this image on a larger screen, it will not spread because it has sufficient number of pixels which are to be displayed on a larger screen. Why we are doing that? And if this is like not good for 65-inch television, then why we are using on website? So the question is, how many number of audience are opening a website on a 65-inch display? So most number of users which are opening websites are having a size screen either 15.6 inches or whether it is a 14 inch if they are using their laptop. And those who are using mobile, the screen size would be from 6 to 6.5 inch. Am I right? So according to those screens, this quality of image is good. But if we want to visualize the same image on a 65-inch display, it will be blur. Any questions? Why the question was, I was talking about why we are reducing the size. The answer was simple, because there are many reasons. Bandwidth was an issue. Another issue was related to the network. Third was loading. The loading will be slow. Any questions on this? If someone is not understanding what I'm saying, absolutely fine. One of the compression technique is JPG compression. It is a compression technique used to significantly reduce the file size of digital images, particularly photographs, and compared with digital cameras. So how exactly a JPG image works? So first step in compression using JPG compression is lossy compression. So unlike lossless compression, which preserves all image data, JPG discard information that the human eye is less sensitive to. So this typically involves the discarding high frequency details like sharp edges and subtle color variations. So second is DCT, discrete cosine transformation. So the image is first converted into the spatial domain where each pixel has a specific location to display the frequency domain. So representing the image component based on a frequency, the transformation helps identifying the area where compression can be applied efficiently. So I was showing here like those areas which can be compressed easily are identified in a spatial domain, and then we are focusing on those areas which can be easily discarded. Like the purpose is to uh, like the whole picture will be the same, but we want to discard the number of pixels which can be discarded, and image will not be affected. The question is, and third step is quantization. So quantization is this stage determine the amount of information to be discarded. So here we have a mathematical process allow a certain quality level to different frequency components. So higher quality settings retain more information, resulting in a larger file size, and quality level to different frequency larger file size. So what we want to say that if we want to stretch to like 50% only, then this image has more number of pixels and more information as compared to this 80% lossy compression, because it has number of pixels are greater, as well as more sharp edges, as well as sharp information visible, which can be eliminated from this. If we are reducing to further like from 80 to 90%, and file size will be like 30 KB, but that pixel like that picture will be blurred in mobile only also. So we are not going to that level. We have to fix that trade-off between file size as well as the quality of image. If we want to decrease the file size, the quality of information or the quality of image will also be reduced. So we have to make a balance between quality as well as the size. Second technique is zigzag coding. So zigzag coding in multimedia is specially refers to the use of zigzag traversal. So we have more number of slides to represent. I'm skipping this slide and moving further. That is very important. So we have multimedia databases. We already discussed. We have text, images, audio, video, and animations for creating a multimedia database. These are the elements which are to be used for multimedia database. And what are the benefits? Efficient storage, advanced search, and organization is like uh, easy. Then we have multimedia database applications like where we are using these multimedia database like education, training, entertainment, medicine, digital libraries. What are the challenges? Like storage requirements, complexity, sometimes security will also be an issue with multimedia databases. Now we are talking, previously we were talking about the JPG compression or like image compression. Now we are talking about video compression. Video compression means uh, we want to compress the video. Like we sometimes we see that if you are downloading pirated movies, so 100 MB movie, 100 MB size is allowed for a full 2 hours movie. So this is due to video compression. So that the quality of the movie will be as per the mobile screen. If you just want to see on mobile, then sufficient pixels will be there in that, but that kind of movie which has a pixel size from 360 to 360 something, or 500 to 500, that can be a size of. So compression techniques related to video compression is spatial compression, temporal compression, and transform coding. These are the techniques we are using for video compression. Then we have a color models. Like we have one of the students was describing RGB and some other color models when I was displaying those uh, hexadecimal color codes. So what exactly RGB? I think you all heard RGB. What exactly RGB? RGB is a full range of colors which is red, green, and blue. And we see that almost all colors are created by RGB. Like if we have a screen display, so each color displayed on our screen is combination of RGB. RGB means red, green, blue. And if we are combining all three, red, green, and blue, then there is a white. If we have a combination of green and red, then the combination is yellow. If we have a combination of green and blue, then the combination is cyan. So these kind of color combinations are there. Opposite to RGB is CMYK. CMYK means C is for cyan, M is for magenta, Y is for yellow. And this is opposite to the RGB. And where this CMYK is used, these colors are used in printers. So if you see that uh, of a color printer, uh, you can easily see that there are only four inks available in a color printer. What are those four? Those four are neither red, neither green, neither blue, neither white. So what will be the colors used in a printer? The colors used in a printer are cyan, magenta, yellow, and black. If you hear that, or like you are seeing somewhere in a printer, then these color combinations are used. But in case of a mobile screen or a system screen, then we are using RGB. Why we are using these colors? Because we want to print in a hard format. So when we are printing, what exactly the combination of these three? Like if we have a yellow and cyan, then there is a green color. If we have a yellow and magenta, then there is a red color. If we have a magenta and cyan, then there is a blue color. So these combinations are to be there. We have another format like YUV. This is a separate luminance, brightness, and prominence color components. And I'm skipping this. These are the formats for video compression like MPEG-1, MPEG-2, MPEG-4, MPEG-7, 21, etc. So these standards are improved over the time from like 1980s to 2025, and further they are improving their quality as well as compression methods. Moving further, then we are talking about video conferencing. If you are here, what exactly a video conferencing is? Whenever we are communicating with someone using a camera is a video conferencing, whether using a mobile call, mobile video call, whether it is from internet based, whether it is from a desk cam or like uh, laptop camera. All these are video conferencing where voice as well as image is in transmission. So what are the major benefits? It brings like together team. Like if we have a team which is separated on different geographical areas, like one candidate is at US and another is in India, another is in Europe, then it is the benefit that all attend a meeting with a camera, then they are seeing that one is next to them. It improves the communication always. Like I'm providing a lecture to you. No one knows from where I'm talking to you, but this is the same as I'm in front of you and I'm talking to you. So no matters what's the location and what's the area I'm in. It saves the travel money. Yes, each time when someone is going for that kind of thing, for just a meeting, it will not be effective. So we have video conferencing, one of the better technique to be used. It is a time save. Yes, definitely. If someone is spending some time in traveling, it is kind of waste of time. Better than audio conferencing for group discussions. Yes, if we have a video communication, so in that case, we can see each other and it will be more effective other than the audio. What are the benefits? We can multi-point conferencing, audio and video transmission is there, screen sharing and collaboration tools. We can easily, like, we are not using, but if anyone want to control the screen of any other person who is facing some problem, so screen sharing is possible, as well as remote tools are also there. We can like control the screen of someone else also. Then the security and privacy. So here, these kind of applications are working on security and as well as the privacy. Where we are using conferencing like for business meetings, education, telemedicines. Nowadays, healthcare, we are using conferencing. Uh, After COVID, we have some like international summits. We are also using with the conferencing. Then we have some other topics related to like multimedia broadcast services, where three different broadcast networks are also there, like terrestrial, satellite, internet-based broadcasting. Transmission technologies are always analog and digital. Like previously, we have a uh, landline phones. So those landline phones were analog based. Nowadays, we have digital techniques like we are using fiber and upgraded mechanisms. So receiver devices, we have broadcast receivers as well as internet enabled devices. Applications of multimedia broadcast services, like we are using radio broadcasting, where AM, FM, digital radio stations are always there for listening music, audio content, news, sports, talk shows, podcast, as well as, and we have also television broadcasting using the same frequency, which is a radio. So all the entertainment related to DTH are to be available. Now then we have an internet streaming. With the help of internet streaming, we have each and everything possible that we want. Video database indexing. This is another separate topic. Application of video database like video content management, video surveillance, media production, video analytics. Like nowadays, these kind of features are available, which are showing the object that this is a person, or this is a building, or this is a car. All these are video analytics tools that are available nowadays. So this is all from my side in today's session, that we discussed multimedia. You guys read more information. I'm sharing all these PPTs. Recorded lecture will always be on your uh, like CMS, and then we are like moving further with uh, question answers as well as some question banks. So I will upload some discussion questions. You will have some discussions over the class. So thank you guys from my side. This was multimedia systems, and I discussed the visual drawing tool names in this particular lecture on one of the slide. If you view the recording, then it will show. So thank you guys. Have a great semester.